Good morning, students. So this is the second part of the applications of integrations. So we are done with the two illustrations of application of integrations where the marginal revenue is given and you need to calculate the demand function. So here we are taking some more illustration that let's see how we can simplify them. So the first illustration is if the marginal revenue is given by MR is equals to 15 minus 2x minus x square, then find the total revenue and the demand function also and find the maximum revenue. So here we have given the marginal revenue and they want to know the revenue function, the demand function, and they want to know the maximum revenue also. So let's see how we will simplify it. So here MR, the marginal revenue which is given 15 minus 2x minus x square. So the revenue function will be calculated by taking the integration of the marginal revenue with respect to x. So here the integration of 15 minus 2x minus x square dx will be revenue function is equals to 15x because it is a constant term. So integration of the constant term is 15x minus 2 constant term x का integral x square upon 2 minus integration of x square is x cube upon 3. Then here 2 will be cancelled out. So the revenue function become 15x minus x square minus x cube upon 3. So here you have the revenue function which we need to calculate. Now we need to calculate the demand function also. So we know that the revenue function is p into x. So the p will be revenue function divided by x. So I will divide x 1 by x divided by the whole revenue function 15x minus x square minus x cube by 3. If I'll divide this x by whole function, then it will be 15 minus x square by 3. So this is your demand function. So from the illustrations we have calculated now the revenue function as well as the demand function. Now the third important thing which we have to calculate, the find the maximum revenue also. To calculate the maximum revenue, to find the maximum revenue, we have to take the differentiation of the revenue function with respect to x because it is a maximum minimum process. We have to take the first differential with respect to x, then take it is equal to 0, calculate x, take the second differentiation of the revenue function, substitute the point and check whether it is negative or positive. If it is negative, this is a maxima. If it is positive, then we say it is minima. So let's see how we will simplify it. Take the first differentiation of the revenue function because we have to maximize the revenue. So the revenue function is taken differentiation with respect to x. So the revenue function is here. We will take the differentiation 15 x का differentiation 15 minus x square का differential 2x. 1 by 3 is a constant term and x की power 3 का differential हो जाएगा 3x square. So 3 will be cancelled out. So here I have the function x square plus 2x minus 15 is equal to 0. After taking this is equals to 0, I will calculate the values of x. So this is a quadratic equation. Split the middle term method. So 2x I have to split in two terms in such a way that multiplication it will be 15 and plus minus will be 2. So I'm going to write here x square plus 5x minus 3x plus 15. 5x minus 3x will be plus 2 and 5 into 3 will be minus 15. So after splitting the middle term, I am able to calculate x bracket x plus 5 minus 3 is taken as common. X plus 5 is equals to 0. Then the first factor is x plus 5, second factor is x minus 3 is equal to 0. So the first value of x is minus 5, second value of x is 3. But x is equal to minus 5 means the quantity is minus 5 which is not possible. So we are not going to consider it because the quantity is which is going to be produced can be 0 or some positive value. It cannot be negative. So we are not considering this minus 5. So what we will consider? We consider only x is equal to minus 3. So we will take x is equal to minus 3 and will take the second differentiation of this revenue function with respect to x and will substitute the value x is equal to 3. So here one time we have to take in the differentiation. Again we will take the differentiation. Then answer will be minus 2 minus 2x. So here in 2x I will substitute value of x is 3. So this will be minus 8 which is negative. So maximum. Hence the revenue function is maximum at x is equals to 3. Hence the maximum revenue will be So the revenue function, which is this, will put the x is equals to 3 to calculate the maximum revenue. So the revenue function will be 15 into 3 minus 3 square minus 3 cube upon 3. So Rx revenue function will be 45 minus 9 minus 9. 3 square is 9 and 3 cube is 27 divided by 9 divided by 3 will be 9. So 45 minus 9 will be 27. Hence the maximum revenue is 27. So we are able to calculate the revenue function, the demand function and the maximum revenue. Similarly, one more example we are taking here. The marginal cost function of manufacturing x unit of a commodity is 6 plus 10x plus minus 6x square. Find the total cost and the average cost given that the total cost of producing one unit is 15. So here in this illustration, basically we are given the marginal cost function. This is a marginal cost function. And we need to calculate through the marginal cost function the total cost and the average cost. To calculate the total cost and the average cost, we have given a condition that if the quantity is 1, we are producing quantity 1, then the cost function will be 15. So let's see how we will simplify this illustration. So here the given thing is marginal cost, which is 6 plus 10x minus 6x square. So to calculate the cost function, we have to take the integration of this marginal cost function with respect to x. So I am going to take the integration 6 plus 10x minus 6x square ka integration with respect to x. So the cost function will be 6x plus 10x square by 2 minus 6x cube by 3 plus c, where here c is a constant term. So now cx is equals to 6x plus 2 is cancelled out by 10, so it is 5x square plus 3 is cancelled out by 6 by 2 x cube plus c. Here 6c is a constant term. So to calculate this constant term, the given condition will be used. So here the total cost is 15 when quantity is 1, when x is 1. So I'll write in this cost function, when x is equals to 1, the cost function, the total cost is 15. So let's see how we will simplify it. The total cost is 15 is taken. It is equals to, in place of x, I'll substitute 1. 6 into 1 plus 5 into 1 plus 2 into 1 plus c. So it is 6, 5, 2 plus c. 6, 5, 11, 2, 13. 13 is subtracted from 15, so it will be 2. So the value of c is 2. So the constant term is able to calculate it. This is 2. So the cost function will be, so here the total cost function will be, total cost is equals to 6x plus 5x square plus 2x cube plus the constant value which is 2. So this is the variable cost and this is the fixed cost, and total become total cost function. So the average cost is total cost function divided by x, 1 upon x, the total cost function. Every term will be divided by x. So the average cost will be 6 plus 5x plus 2x square plus 2 upon x. So this is your average cost. Thank you.